Here we are going to show the different categories of gas leaks that occur during laparoscopic and robotic surgery. We've used clear and optical imaging in an operating theatre to show the gas vortexes that occur around trocars and instruments during operations. The first category is leaks that result from intentional actions by the surgeon. One example is opening the tap at a trocar to vent gas to clear smoke from the internal operative field in the presence of a pneumoperitoneum. Another example is removal of ports without prior desufflation of the pneumoperitoneum. More mindful practice and filtered smoke evacuators address this category, and these have been the predominant focus of recent guidance for surgery in the COVID-19 era. Leaks can also though occur inadvertently via the trocar incision, either because the wound has been made fractionally too big or stretches during the case due to instrument and trocar movements. The third category involves leakage inbuilt into trocar or instrument design. For instance, removal of obturators induce leakage as the trocar valves are open during this time. Here is an obturator being removed from a 5mm port which is needed for placement or replacement of trocars. Some obturators are hollow and have holes in their shaft, such as this Asan port. Optical ports, of course, by their mechanism of action, induce a lot of gas flow during their placement. Of course, if the gas has not been inside the patient, it can't confer pathogenic risk. Gas can also leak during insertion and removal of instruments into and out of trocars. Robotic instrumentation leaks gas through the instruments themselves, as we show here in this simple and reproducible test. First, a glove is placed over the instrument head and tied in place. Next, a gentle positive pressure is applied to the instrument tip. After cessation of insufflation, you'll see gas leaks back through via the instrument tip. To see better where it's leaking from, here the instrument head is submerged in water, and again a positive pressure is applied to the instrument tip. There are several areas of leakage, some of which are sites of attachment into the robot, although these are not intended to be hermetic seals. It's clear so that leakage cannot be obviated by optimum current technique alone.